valence electrons, and ionic compounds. Just a little review here. Learning targets. So the enduring understanding stays the same, shows pattern in the electronic structure and trends in atomic property based off the periodic table. But after today, you should be able to determine the likelihood that elements will form an ionic compound based on the number of valence electrons. And you're looking at the typical charges that the atoms form when ionizing, turning into ions, as governed by their location on the periodic table. Then you should also be able to identify elements in the same column or group tend to form analogous compounds. So ones that are similar in nature. The way that they form compounds are similar if they're in the same group is what we're talking about there. One thing to review, of course, the valence configurations are due to the blocks on the periodic table, the S block. So these guys are NS1s here. These would be NS2s. If we're looking at the boron group that has 3 valence electrons, NS2 NP1s. Say the oxygen group here, that'd be NS2 NP4s. So if it's oxygen, it's 2s2 2p4. If it's sulfur, it's 3s2 3p4. If it's selenium, it'd be 4s2 4p4, and so forth. This is based off the periodic table is what I'm getting at. Now, typical charges of atoms are governed by their location and their valence electrons. And the location, of course, determines the valence electrons, as we just saw in the previous slide, but that's also going to designate the typical charges. So if, you know, group 2 is NS2, 2 valence electrons. They have a tendency to lose those 2 electrons in order to look like the nearest noble gas. In that case, it would be helium if we're talking about beryllium. And so the 2 valence electrons ends up being a +2 charge for that column. So this column, they're going to all form +2 charges because they have 2 valence electrons. Now, if we're looking at, say, something over here, like the nitrogen group, which has 5 valence electrons, due to the NS2NP3 configuration, because 2 + 3 is 5. Remember, these are anions. The metals, or the non-metals over here are anions. They typically gain electrons to form that noble gas configuration. So if it has 5 to start with, it's going to gain 3 and form -3 charges in order to become like its nearest noble gas over here. So it does form a pattern. Group 1 are +1s. Group 13 usually are the 3 pluses. Group 4 or 14, they typically do covalent bonding, like carbon can form carbide. And then, of course, you have the tin and the lead down here that are multiple oxidation metals that do +4s as well in the metal category. But these guys typically do covalent bonding and don't form a whole lot of ionic compounds. But so we do call this column the ±4 column, ±4 column in some exceptional cases. And then here, -2 for oxygen group, -1 for the halogens, and then the noble gases don't really form ions, so their charge would be 0. +1, +2, +3, ±4, -3, -2, -1, 0. It's following the typical charge pattern on the periodic table. Through in this one also, these rings are for the principal energy levels N, like energy level 1, energy level 2, energy level 3. Also throwing in the basic dot structure off of the valence electrons. So remember 1 dot, 2 dots, 3 dots, and so forth. So another way of looking at the patterns on the periodic table, of course, the transition metals would be inserted there on this particular graphic. I did a summary by groups here with an example for you to kind of put it all together. The group number up here, the valence electrons, the symbol of a particular example, what the charge would look like on that symbol, and then the valence configuration. So, you know, just basic here, one to study. That goes +1, +2, +3, plus or -4, -3, -2, -1, and then 0. So following that pattern on the periodic table. This is a nice graphic to refer to. Now for the fun exercises. So let's think about this. Atoms of element Z have the electronic configuration shown below. The compound most likely formed with potassium K is. Any ideas as to where I should start? What should I look at first? What do I need to do with this configuration before I can figure out what compound is going to be formed with K? I really need to identify the element or the group. Yeah, so I need a periodic table. So pull out that periodic table. Let's take a look. This is looking at valence electrons, 4s2, 4p4. So 4s2, 4p4. Obviously, it should be selenium. Now that I identified the column, what kind of charge is this going to form? A -2, good. -2 charge, very good. Now that I know that, I can figure out my compound because K and Z, I know Z is -2 because it's really selenium. But what's K's charge? +1. Once I have identified the charges, I not write the formula. And what do you do to write the formula? Has to equal 0. Good. Yes, the charges would have to equal 0. I prefer the crisscross method in this case. The 2 becomes the subscript on K. The 1 becomes the subscript for Z. So it's K to Z. But you can always check that case. This is going to be 2 times +1, and this would be -2. So yes, it should add up to 0. Very good when writing the formula. So K to Z would be our compound. What compound would most likely formed? That would be K to Z. Exercise 2. Chlorine reacts with an element to form with the element lithium. Based on periodic properties, identify a molecule X2 that is likely to react with lithium in a similar way that chlorine reacts with lithium. Justify your choice. So, what other molecule, X2, would react similarly the way that chlorine reacts with lithium? Any ideas? When something's reacting, what's really actually happening there? What's changing, or what has to take part in the reacting process? Valence electrons. Yes, exactly right. Valence electrons are what is reacting. So we want something that's going to be similar to chlorine reacting with lithium. So what would be one that you could predict could be X2 then, react similarly? Yes, things in the same group because they have the same number of valence electrons. So pull up your periodic table, look in chlorine's group. What do we have? We have fluorine as an option. We have bromine as an option. We have iodine. We really don't, pay much attention to AT because it's very little existence. But yes, pick a halogen. Pick a halogen. Any halogen is fine with me. So, but remember the halogens are diatomic, so you need to write them as diatomic, just like it says right here, be diatomic. So any of those would do. So keep that in mind. Now it says justify your choice. Well, I'm justifying my choice because they are in the same group. They have the same number of valence electrons, so they react similarly. Basically what's going on there. They're in the same group, they have the same valence electrons, so they should react in a similar fashion. This one's a little bit of a trickier one. They gave you this ionization energy chart. The ionization energies of an unknown element X are listed in the table. Which of the following is most likely the empirical formula of a compound formed from element X and sulfur? I need a compound here. So I need to know stuff about sulfur and X. What can I find out about X from the table, by the way? What is that going to tell me? Look at these numbers. What are they telling me? They definitely give me a hint. When are we starting to take away core electrons exactly? And where does that happen? When do we start taking away core electrons? At the fourth. So this is the core electron. That's where they begin. So that means this element has how many valence electrons? Has 3. So we know X has 3 valence electrons. What do we know about sulfur? And we can look on our periodic table. What do we know about sulfur? Yes, it has 6 electrons, and yes, it has a -2 charge, so you look that up, -2 charge. If X has 3 valence electrons, it's got to be somewhere in this group. So what would its charge be? 3 valence electrons in the boron group. What would its charge be? Yeah, it's +3. So if X is +3, S is -2, what's our compound going to be if we write out our compound? X2S3. Exactly right. Isn't that fun? Yay. And they made us talk about ionization energies again. Huh. We love that, right? Love that. All right, next. Another ionization energy chart. Woohoo. Oops. Didn't mean to go there. Back. All right. Another ionization energy chart to look at. Ionization energy of unknown element X are listed in the table. Which of the following represents the electron configuration that corresponds to the valence electrons of this element? So what's the ionization energy chart telling me again? 5 valence electrons. Good, because this one right here is where the core starts. That's a huge jump between the 9,000 and the 53,000. So this is a core electron here. That means this element has 5 valence electrons. Good. Now, I can look at my periodic table. Which one has 5 valence electrons? That's going to be anything in this group. And what's its configuration going to be for valence electrons? For valence electrons, anything in that group, that's going to be an NS2, NP3, right? Anything in this group. And so that means our answer has to be what? C. C is the correct answer. Check. That would be the right answer. Very good.